Hi guys, welcome back to my channel. Today we're going to be focusing on functions and what are functions and relations, how to tell if something is a function, and the basics of domain and range. So let's get started. So what is a relation? A relation is between variables, let's say x and y, and is any set of points in the x and y plane. And we say that the points connect these two variables. So an easy explanation is any equation of a graph, let's say y is equal to x squared plus 2. Any equation of a graph that is connecting two different variables, x and y, let's say, or it can be z is equal to g squared plus 3. Connecting two different variables is a relation. And that's basically it, and it's very simple to understand. That's what a relation is. Now let's move on to what is a function. So a function is a relation between two sets, but it assigns every element of the first set. Our first set would be, let's take x. Yes, that's our first set. And to exactly one element of the second set. Your second set being y. So that means it is still a relation. So x squared plus 2 is equal to y. It is still a relation, but it means that every x value has one unique y value. So x1 will be equal to y1. In a function, you will never see that x2 and x1 both equal to y1. You will never see that. Then if this ever happens, that equation is not a function. Not a function. Not function. Yeah? Okay. And I just want you to read this real quick. It will come back to this at the end. But this is the basics of domain and range. I just want you to keep this in your head. So the set of all inputs, your inputs are always your x. So the set of all inputs, which is your x, is the domain of the function. All possible values of x that you have is your domain. And the set of all outputs is the range of the function. So the result of all your inputs is the range of the function. So the possible values of x, the possible values of y. I just want you to keep that in your head. And I just want to go over this one last point about functions for you to remember. So every single function is a relation, but not every relation is a function. And we'll go over this in the next slide. So this is a different way to visualize a function. So over here, you see that your input, let's say this is the function f of x, and you're plugging in your inputs, which is x, and it's giving you outputs, which is y. So f of 3 has given me 8. F of 0 has given me 7, and f of -1 has given me 5. Now you see here for each individual unique input that we have, -1, 0, and 3, we have gotten a different output, 8, 7, and 5. Yes? So that means that every single x value has a unique y value. So this can be, f of x can be determined as a function. So this can be classified as a function. Now let's move on to example 2. Let's say this function is defined as g of x. So g of x, we plug in g of 3, again x and y, these are your inputs and outputs, x is your input, y is your output. So g of 3 has given me 8, fine. G of 0 has given me 7, okay, that's fine. G of -1 has also given me 7. This is where it's not fine. As we go back to our next slide, previous slide, sorry, x of 1 has given me y1, x of 2 has given me y1, also in the same function. So this cannot be a function. So this would be classified as a relation, not a function. This would be a relation. G of x is now a relation. So I want to come back over here and just revisit this. So every single function is a relation, but not every relation is a function. Remember, our definition of a relation was just an equation connecting two different variables. It had no specific requirement of every input having a unique output. So every unique x value having a unique y value. So that is why most equations, almost all equations, are classified as relations but not functions. Great, let's move on. So now we'll look at how to know which relation is a function. So there are two ways of doing this. The first is the algebraic test. So that means that they might specify a domain of x values. So a domain is the x values that you can input. So they might limit your domain, saying that x has to be greater than or equal to 0, but has to be less than or equal to 10. So this is your domain. All the possible x values, all the possible inputs that you can have is your domain. So essentially what you do here is you plug in every single possible x value that you have into your function or relation, into your relation to test whether it gives you a unique y value, a unique output for every single x value that you input. This is a very lengthy process, and I would not advise using this whatsoever unless the domain is very small. So this is very lengthy, but it is one way you can do it. The easier way is the geometric test or vertical line test for functions. So here we draw every possible vertical line on the graph of a relation. And if each line cuts the graph at most once, then the relation is a function. And I'll draw this out for you. If at least one line cuts the graph more than once, then the relation is not a function. So I'll show you how to do it over here. So a vertical line test is you draw every single vertical line that can exist. That doesn't mean like literally every single vertical line, but you just draw as many as you can, as many as you can see, and you see whether each vertical line that you've drawn cuts the graph at most once. So let me do it for this graph too before changing color. So I'm drawing all the vertical lines that I can see right now. Obviously your lines will be better. It should be straight and vertical. Draw it with a ruler, please, in the exam. Yeah, so I've drawn most of the vertical lines. So now I'm going to mark where it cuts on the graph. So my vertical lines are cutting here, 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 and here. So you can see that in this graph of here, every single vertical line cuts the graph only once, one time, at most once. That's what it says over here, right? If each line cuts the graph at most once, then the relation is a function. So it cuts at most once, only once. So this can be classified as a function, right? Now let's move on to the second example that we have. So, okay, this is fine. It only intersects once. But here, twice, 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 and twice, and twice. So this relation, sorry, the vertical line test, it fails the vertical line test. Because if at least one line cuts the graph more than once, we have multiple lines cutting the graph more than once, then the relation is not a function. So because the vertical lines that I have drawn cut the graph more than once, this cannot be classified as a function. This is a relation. I hope that makes sense. Let's move on now. What is domain? Sorry. What is domain and what is range? So, this is the same definition that I pasted before. Hopefully you remember it. The set of all inputs, so our x values, is the domain of the function, and the set of all outputs is the range of the function. So the outputs are y. So over here, this would be your x, and this would be your y. This would be your x, and this would be your y. So in many questions, they might limit your domain at first. They might say, again, x has to be greater than or equal to 0, or x has to be less than or equal to 10. They might do this, or they might ask you to determine a domain. So let's say you have your f of x, your function, is equal to square root of x, right? And they'll ask you, what is the domain of this function? So clearly over here, you can't square root any negative number. You can't square root negative x. So over here, your domain would be x has to be greater than or equal to 0. That would be your domain. That's how you find out your domain. You do it by trial and error, or you just, it's common sense in some occasions. And then your range is all the resultant values of your inputs. So from 0, the range would be from 0, so y has to be greater than or equal to 0 also. Because you'll only get positive values, there's no negative, and square root of 0 is 0. And that's the least possible value that you can get. So that's the domain, and that is the range. So this is the domain, and this is the range, R and D. And that's how you figure out your domain and range. This is a very basic problem, but I'll be going into it more in the next functions video, hopefully. And I'll be going through some questions too. So this is just a practice question for you to try. If you can, draw the vertical line test and figure out if you can see whether this is a function or a relation. And yeah, let me know. I'll be pasting the Canva slides in the description below, and you can the answer is on the next slide. So yeah, thank you very much for watching. I hope you liked the video today. If you did, please like, share, and subscribe. Thank you. Have a good day.